Okay, so with all that said, the first step of constructing a project on a prototyping shield is to just get a general idea of where you'd like components to go. So I am trying to put those two aside next to each other and zoom out so you can get a complete picture. So what I would like to do ideally is to replicate as much as possible the layout of the components on the breadboard onto the prototyping shield. Mainly, I am very concerned of making sure that my light sensors are at the front of the shield, facing forwards with not much obstructing the view in front of them. And that I want the power system on the rear of the board so that I can connect the wires from the battery packs directly onto the screw terminals. Now with the capacitors, I'll be using just 2 capacitors, and I know in the past that I've mentioned that you should connect the capacitors as close as possible to where the consumption is, in which case I've got 3 headers here for the motors, but because of the amount of space that I've got here, it just makes it a little bit clumsy to put the capacitors even closer. So instead I'm going to take advantage of the power rails that I've got here and just hook 2 of these capacitors there. And actually you could just hook 1 capacitor instead of both, and then see how your robot operates. And if you think that you need to put another capacitor, you can always solder one later. You can also go for smaller capacitors. These ones are quite large, as I've said. They do take quite a bit of the real estate here. Anyway, so I'll be going with 2 capacitors. Then I've got my left and right LEDs, so I'll be using smaller LEDs instead of the 5mm LEDs that I've used on the breadboard, just to conserve space. And you still get the same effect anyway. You can still they're bright enough to be able to see them. I've got my 2 switches here, one for the motor and one for the Arduino for the power. I've got the 3 headers for the motors. You can connect them in a variety of ways, but in order for me to be able to remember easier which one is which, I'm going to be using this one here for the left continuous rotation motor, this one here for the macro servo motor for the ultrasonic distance sensor, and that's going to be for the right continuous rotation servo. Let's put that back together. There you go. I'll plug the potentiometer here for the calibration, and I'll be using a header for the ultrasonic distance sensor. I haven't placed the resistors, so the resistors are the only components that are missing from this mock-up, and nothing is soldered right now, so I just placed the components around just to get a general idea of what the layout should be here. Give a bit of space. So remember that if you pack the components too close to each other, you will have trouble soldering them. So I think I've allowed for enough space between the components to reduce the difficulty in soldering. Another thing is that instead of using 2 sets of screw terminals for the batteries, I decided to use a triple one, just a single but triple one. So the idea is that the middle will be the common ground, and then on one side I'll have the positive voltage for the motors, and the other one will be the positive voltage for the Arduino and then the sensors. Alright, so at this point I'm going to take a picture of my layout so that I can use that picture as a reference as I'm going through the construction. So I'm just going to use my phone, take a picture, and then use that picture as I'm going through and constructing the prototyping shield, because I will have to remove all the components in order to start then attaching them one by one. So the process from this point onwards is going to take a couple of hours. I'm going to record all of it, but I'm not going to subject you to looking at my complete soldering process here. I'm going to stop at specific points where I think something important is happening, but the rest will be in fast forwards. So let's begin. I'm going to start with the screw terminal and the power system. So I'm going to remove everything else so it doesn't fall out. Easy to do this by hand. Okay, so flip that over. Get my soldering iron. Untangle it. Make sure I don't get burned. And start soldering. Okay. Great. So don't forget which one is which. I plan to use this screw terminal for the positive voltage from the motor and this one here for the Arduino. And the one in the middle will be the ground. So I'm going to use this little label here that I printed on a little label printer. Let's see if I can get the sticker removed from its backing. There you go. And just attach that label there. So the one on the left will be the motor. So that's the motor. I've got another little sticker for the Arduino. It just says A. It's important to label things, otherwise you forget which wire is supposed to go where, what the role of each wire is. So I prefer to do that as I go. So there's the Arduino. Alright, the next thing to put in. So then I'd like to connect the 3 headers. I'll put the 3 headers next. So alright, so let's have a look. So the 3 headers are done. I'm going to go now and attach the female header for the ultrasonic distance sensor. And just with the headers, just remember that the headers come in long strips like this, and then or like this. Then just need to cut the amount of pins, the number of pins that you want off the header. With the female headers, a little bit trickier. You typically have to sacrifice one of the pins. So for example, if I say I'd like a header with 4 pins, then you need to put your cutting tool closer to the 5th pin. So I've got 1, 2, 3, 4, 5. So you put your cutter closer to the 5th pin in order to make sure that you've got 4 good pins there, and you cut, and you can see that 1 pin just fell off because we cut onto it, and then what remains is just a nice piece with 4 undamaged pins that you can use. So I'm going to connect the header for the ultrasonic distance sensor there, and use a bit of tape to hold it together. Great. So the headers are all done. Next, I'll plug in the potentiometer. So I'll plug in the potentiometer, say here, almost in the middle. Great, that's in as well. Next, let's do the switches. So with these switches, you might have a different set of switches than the mini switches that I have, but just wanted to show you how they work before we plug them in. So to do that, we'll use the multimeter and again set it to continuity testing. And I'm going to attach one electrode, one probe. Say, just switch hands like that. All right, so one probe will go here and the other one here. So testing for continuity, I should select continuity in the meter. Yep, so you can see that this is now connected. So the first pin on the left with the middle pin are connected when the switch is at this position. I'll flip it over to that position and let's test again. So this is the off position. So when the switch is at this position, it is off. I'm going to test the other two pins just in case. It's not easy to do this. All right, so when the all right, so that when the switch is in the second position, then we've got the two pins on the right side that are connected. And when the switch is at this position, then we've got the two pins on the left that are connected. Yep. Okay, so we'll use this information to say that, okay, when the switch is at this position, it is off. And when it is at this position, it is on. So I will be connecting the positive wires from the battery to the two pins on the left after I connect them onto the breadboard. Another thing about the mini switches that I've got here, where's the other one? Yep, is that they've got a little lip, a metal lip here that you can use in order to secure the switch against a surface. It could be a PCB, could be perhaps a plastic casing, but these require holes that are of a larger diameter than the ones provided on this prototyping shield. So unfortunately I won't be able to use them because I don't want to push them hard onto the PCB in case it breaks it. So that's why I've lifted them away to the side, and even better, I will try to actually remove them completely. And through the solder there'll be enough mechanical tension there to keep the switch in place. Haven't been able to find a switch that has securing lips or mounting lips that work well with a prototyping board. So I'll just remove those lips. Just going to bend them over until they break off. There you go, that's off. And that's gone as well. Okay, and I'll do the same thing for the other switch. So switches are in. Next, to do the LEDs with their resistors. Now, because once I insert the LEDs onto the prototyping breadboard, I will have to cut off eventually the pins, because as you can see they stick out too far. At that point I won't be able to use the length of the pins to tell me which one is the anode and which one is the cathode. So what I'll do to remind me is that I will strictly follow the schematic here and connect the current limiting resistor onto the cathode. And this way I will know that I will need to wire the other end of the current limiting resistor onto a ground wire or ground trace, and that the free end of the LED to one of the pins 5 or 4, depending on whether it's the left or the right LED. So now that I've made this mental note, I can go ahead and connect the LEDs. I'll put it a little bit towards the right to leave a bit of space on either side in case I need to extend a wire. So the anode is on the left, and I'm going to grab a 330 ohm current limiting resistor and plug that onto the cathode. So to preserve a bit of space, I'm going to bend the pins of the resistor as far as possible, so that I only occupy just a few bits, a few holes on the prototyping breadboard. So I'll do it like that. Just push it in gently, like that. Now, to make sure that things don't fall out, I will bend the LED's pins slightly to make sure that the LED stays right, like that. So let's do some soldering now. So for now I'm going to leave the rest of the pins as they are. I may need to use this extra length. So what is there to do next? So the next thing to do is to connect the photosensors with the resistors for the voltage divider. Now with the resistors you could also consider using a header. So if you use a header like this, you'll be able to remove the resistors at will. I can feel enough tension inside the header that will hold the resistor in place, but I've had experiences in the past where the robot was behaving erratically, and that's because when I was using headers, it was due to the movement of the robot, the photoresist was slightly coming off the header momentarily, and that was causing degradation of the signal. So the signal wasn't good at that intermittently, and that caused a lot of headaches. So because of that, I personally prefer to solder the photoresistor directly onto the board. And if I need to remove it, that's an easy enough operation to do later. I just want to make sure that the connection is nice and solid here, and that the photoresistor will be working as expected instead of not working properly due to a poor connection with the header. So that's what I'll do. I just connect it directly onto the prototyping board. So that bit is done as well. Photoresistors are in. And looking at my schematic diagram, I also need the 10 kilo ohm resistors that match the photoresistor in the voltage divider right here. So let's grab 2 of those resistors. So I've got a 10 kilo ohm resistor, and I'm going to, just like before, I'm going to bend the pins so that I use as little as possible of the available space on the prototyping board, like that. Now turn it over and slightly bend the pins to keep the resistor in place. All right. Just like before, I'm going to trim the other side of the resistor in order to provide for the minimum amount of pin length, as opposed to create a nice bridge between the resistor and the photoresistor. Okay, so there you go. That's a nice bridge. Okay. So looks good so far. So we've got all the components that we need on the board. Just going to do one last check with my photo, make sure I'm not missing anything. So I've got the photoresistors, I've got the headers, potentiometer, switches, LEDs with the resistors. Oh yes, the next thing to do are the 2 capacitors, and then we can start doing the actual wiring between all these components. So let's plug in the capacitors. So because I'm plugging the capacitors here, which of course are meant for the motors, I'm now making a decision to use this power rail, the ground and a positive voltage power rail, specifically for the motors. So this is not going to be 5 volts anymore. This is going to be 6 volts or whatever voltage you provide for the motors. Okay, so that's all in terms of laying out the components on the PCB of the prototyping board. So the next thing to do is to start doing the wirings. So for that, we'll have to refer to the diagram very often, or have a look at the breadboard prototype. Before concluding this section of the course, I'd like to show you what the robot looks like now without the breadboard. So all I did was just to cut the cable ties that were keeping the breadboard together. A lot of space has been freed now, and then just use a single cable tie here to bundle the motor cables together so that they're not flying all over the place. I didn't tie down the cable that comes from the ultrasonic distance sensor, just to allow it to move freely around left and right. So as you can see, there's a lot more space now left on the robot that I'm sure you can find something else to do with. So consider of other options here that would allow you to add additional capabilities to your robot. One thing that I did not include onto the prototyping board was a provision for a header for the Bluetooth module, so I can use it for telemetry and for calibrating the robot away from the computer without it being tethered. So I was thinking of having a header, female header, perhaps around here or around here. There just wasn't much space available, as I was also looking at what is happening in the bottom part of the prototyping board. So what I decided to do instead was to take advantage of the alignment of the pins. So as you know, the Bluetooth module needs to be connected to the receive and transmit pins on the Arduino, and those are these two pins here on the left side of the header. So pin number 0, which is the first one from the left, is the receive pin, and the receive pin aligns very well on the transmit pin on the Bluetooth module. The pin right next to it is pin number 1 on the Arduino, and it is the transmit pin, and that aligns again very well with the receive pin on the Bluetooth module. So in other words, all I've got to do is to plug the Bluetooth module in like this. So just the rightmost 2 pins into pins 0 and 1 on the Arduino, and that connects the receive pin of the module to the transmit pin of the Arduino, and then the transmit pin of the module to the receive pin of the Arduino. And then we just need to connect power. So for power, you can just get a bundle of 2 wires, female, male, on the other side. Connect that to connect the red wire, just for consistency, to VCC. I remove it so I can do this easier, like that, and plug it back in. So we've got, sorry, I've done this the other way around. Keep doing those mistakes. Yeah. It's amazing I haven't burned anything yet or shorted anything. So VCC is on the left, and that's where I'm plugging in the red wire, and then the brown wire goes to ground. So then I'll plug in the module on the receive and transmit pins. And to power the module, I'm just going to plug the red wire to the 5V pin and the brown wire to ground. And having done that, I'm going to turn on just the Arduino part, not the motors. I don't want my robot to fly off. So the Arduino is now on, and you can see that the red LED, indicator LED of the module, is blinking. Okay, you can see it now. It's blinking, which means that the module is advertising its existence. So let's go to my computer now. My computer has detected the module, and I'll try to pair it. All right, I need to enter the key. So it should be correct, 1, 2, 3, 4. And the module is now connected. Great, now let's go to the Arduino IDE, connect to the right port. It is, and then bring up the serial monitor. Great, so we've got communications, and the robot is working, and at the same time sending the telemetry to my computer. So that's a simple way for you to have a wireless Bluetooth capability with your robot without having to make a special provision for it on the prototyping board itself. So with all that said and done, let's conclude this section and move on to the next final section on what is it that you can do from this point forwards with your robot. Welcome to section 7, the prototyping shield.
So now that you have a completed robot assembled and wired and even tested, which means that your completed sketch is also calibrated and functioning well, we'd like to take a little bit of additional time in order to finish with the robot and produce a final high quality gadget. So in this section, number 7, I'll show you how to move your design from the breadboard and onto a prototyping shield in order to produce a final high quality result. So we'll spend a bit of time first talking about the prototyping shield, then explain how to place the components on it, do the wiring, and of course the testing. And as always, there's a quiz at the end of this section.
Great, so at this point we've got the assembled and wired prototyping board, and we are going to test it. We're going to replace on the breadboard with this nice, I suppose, well, I think it's nice looking board. The way we'll do this is I'm going to remove all the jumper wires from the Arduino and then plug the prototyping board on it. Then I will plug in power to the screw terminals, plug it into the computer in order to upload the final sketch, and then see if all the motors, the sensors, and the LEDs are working. I'm not going to remove the breadboard yet from the chassis, just until I know for sure that the prototyping board, it works as expected. All right, so I'm going to remove all those wires. And the screw terminals that come out of the batteries, since those will be reconnected to the prototyping shield. So there's one, and there's the other one. All right, so that's done. And I'm going to plug the prototyping board on it. Okay, just try to get all the pins to align without bending them. There you go. Now, you may have noticed that in the meantime, I've also added a few more stickers just to let me know what the purpose of each pin is and each header, so that I know how to connect the headers. And I've got these switches turned off. All right, next I'm going to unscrew the wires from the battery. This is the motor battery. I'm just using a 9-volt battery for the motors. Sorry, a 9-volt battery for... Yes, that's for the motors. I decided to use a 9-volt battery for the motors. Sorry about that. It just got a bit more capacity for my testing. All right, so the black wire is a common ground that will go in the middle. I'll turn it to the side so you can have a better view of this through the side camera. It's a little bit loose. Actually, I shouldn't do that yet. I should also get the wires from the other battery. This is the battery for the Arduino. It's a 6-volt battery pack, sandwiched in between the two parts of the chassis. So I'm going to take the two black wires and together insert them into the common ground terminal, like that. Make sure that it is nice and sturdy and not loose. All right, that's done. Now for the Arduino, the red wire will go into this terminal. Right there. Okay, that's nice and sturdy. And the last one is for the motors. So that is going to go onto the left screw terminal. Loosen it up a bit. It's pretty tight. Okay. Great, so these wires are nice and sturdy. Just wonder now, if I switch on the Arduino, switch this one here. Okay, so yeah, I've got, so this, the motor, sorry, the Arduino already had version 4 of the sketch loaded, so you can see that if I put my hand over the photoresistors, you can see that the LEDs react appropriately. So that is good, I suppose. So next, let's plug in the sensor. So we've got the positive on one side, we've got ground on the right side. So that the positive VCC is a green wire, so that means I should hook the ultrasonic sensor like that. All right, then off to the motors. This is the right motor. The right motor should be connected on these headers. You can see that the negative, the ground, is this pin here. So that should match the black wire. So the orientation for the motor should be this, like that. I haven't switched off the motors switch, so the motors are still switched off. Then I'll go for the left continuous rotation motor. And I should follow the same orientation. I'll just remove the male header that I held on there earlier. So the black wire should go towards the left, like that. And finally, the micro servo. Remove the jumper wire, sorry, remove the header, and plug that in the middle, like that. Okay. So let's turn on the motors switch, see what happens. Oh, okay. Anything happens? Let's switch off some lights. Quite stressed about this. Okay. Okay, so I'm going to upload now the sketch to the Arduino and do a bit of testing. So this is the final version 4 sketch. Oh, okay. So let's try it out. Let's put an obstacle in front of the sensor. Yep, great. Right, and let's bring up the monitor as well. The reason the motors were not working earlier is because I didn't have the appropriate sketch on, so that sketch was a version that involved the calibration and testing of the photoresistors, but not of the motors. So I've got just one light in front of the robot right there, so we're going to use that light to test the operation of the robot. So right now it says move forwards. I'm going to tilt or move towards the right instead. I should also switch off another light that I've got that is skewing, that is corrupting our results. All right. This is move right, forward. Okay. And you can see that the threshold is 927 and right now the left and the right resistors are about 670, so I'll move a bit closer to see if the motors actually stop eventually. I'm actually hitting the light now, so I'm going to increase the intensity of the light just to see if we can get the readings from the left and right a bit higher in order to go past the threshold. Okay, and the motors stop. Great. It's good to see. And then they stop. I'm going to move back. And now the robot says move to the left. Okay, moving to the left. Okay, now it says move forwards. So from what I can see, the robot works okay. It will still need calibration, of course, because the components that I've got on are different. So the photoresistors are different, so they've got a slight different sensitivity to light, and they're different batch. The potentiometer is different as well, although I don't think that would affect the operation by too much. So you will need to calibrate the robot with the new components, just like you did with the components on the breadboard. Okay, so I'm just using my finger to hide or to remove, to reduce the light going into the photoresistors, just to see how the robot reacts. So that is good. Reacts as expected. I'm going to remove the cable now from the computer. Just let it work on its own and see what it does on my table. Well, okay, it's gone towards the light and it can't get closer to the light because of the way that I've calibrated it. Let's say that I'd like it to stop around here. I'm going to use my screwdriver to calibrate the potentiometer to bring down the threshold towards... I need to have this tethered before I can do it. Oh, actually, it's done it. Yeah, this is fine. So let's start again. Turn one more light on. Sorry, off. So I'm going to start at this position here. It's just about 30 centimeters away from the light. And then it's going to turn towards the light. Get a bit closer. And eventually it will stop. Great. So based on what I see at this point, I'm confident enough to remove the breadboard of the chassis, and from this point onwards just play around with what is on the prototyping board. Of course, you will have to put your robot on the floor and just follow this and repeat the same process as you saw in the previous few lectures where we calibrated the robot to work on the floor. That's because the conditions on the floor are different to those on the table. The light is much closer, and the obstacles around it are much harder to simulate on a table than it is on the floor. So, but all the motors are working as expected. The robot itself with its sensors are working as expected. So I can confidently say that the construction of the prototyping board was successful. Hi. So now we've got a robot that works. It may not work perfectly, but it works well enough for the purposes of this course. And of course, you can always continue to improve it as per the specific issues and problems that you find with your construction. One more thing that I'd like to show you is how to convert this mess of wires on the breadboard into something more tidy, and in particular by using a prototyping shield like this one here. So the actual functionality of the robot is not going to change by doing this, but it's going to make it a lot more tidy, and it's going to be a lot more easy to use in the future and play around with. So you're not going to have to worry, for example, about a wire becoming loose and that affecting, of course, the operation of the robot. Everything will be nicely constructed on this prototyping shield. It will be soldered in. There's not going to be any loose wires to cause problems. So again, this is not a necessary step, but if you feel like you'd like to tidy things up and also practice your soldering skills and take a project one step further from the breadboard into the prototyping shield, then follow along. Now, this process of converting this into this should take a couple of hours to complete, and it's a good idea to put aside that block of time so that you don't have to stop and start again. I'm going to start by talking a little bit about the prototyping shield first before moving on to the construction, and also about the tools that you will need to have handy before you get started. So first, about the prototyping shield. So what the prototyping shield is a breadboard that is not populated with any components that comes in the shape, including the headers that hook nicely onto an Arduino Uno. So I'll show you what I mean. So here's a spare Arduino Uno, and with a prototyping shield you can just plug it onto the headers of the Uno without bending them. So just be a little bit careful because those headers are quite long. Let's try again. There you go, one side is in. Alright, there you go. Press on either side to plug it in. So the prototyping shield will plug in directly onto the headers of your Arduino Uno. And then on the prototyping area inside the shield, you can plug in your components. So anything that can go onto the breadboard of at least this size, a mini breadboard, can be soldered into permanently on this prototyping shield. So then when you want to play with the project that you constructed earlier, you just hook it onto your Arduino. If you want to use your Arduino for something else, you just unplug it, use your Arduino for something else, and come back later to your project. There's a lot of prototyping shields out there, and they all have their own little I suppose differentiators and different features. This one from Arduino Tech is one of the simplest ones that I could find, and I really wanted something very, very simple without any bells and whistles at all. So this prototyping shield has got a general purpose prototyping area here. So all these holes that you see are not connected with anything else. They are just individual holes with tin around them so that you can solder components or wires onto them. And on the left side here, you've got the power area, so you can hook in your 5 volts or other voltages. In our case, we're going to provide different power for the motors and for the Arduino itself. So that's going to go through here. Before you start soldering things onto it, just become familiar with these different areas. To do that, it's very handy to have a multimeter nearby. So I'll show you what I mean by that. So take your multimeter with your prototyping shield, and I'll remove it, unplug it from the Arduino because we don't need that to be connected at the moment. When you're working on the prototyping shield and you're attaching components, don't have it connected to your Arduino. So take your multimeter and set it to continuity testing. So it makes this beep when your probes are on a part of a circuit that is directly connected that directly connects the two probes together. And you can see that little symbol here that looks like a Wi-Fi symbol that indicates that the multimeter is set to continuity testing. So you can see now, I'll zoom in the camera so you can take a better look. We don't actually need to be looking at the screen of the multimeter, just to be listening for the beep. So let's do a bit of testing. So first of all, the power segment. You can see that in my case, the Arduino Tech prototyping shield has got two rows that are all connected to each other. So two rows where individually the holes are connected to each other. So I'm going to touch here, for example, on the 5-volt column, I should say better. And you can see that all these holes are connected to each other. So you can treat these two rows as the power rails on the breadboard. So remember that our breadboard has two power rails, the positive and the negative. The positive here and the negative here, and we can then plug in our jumper wires to those power rails if we want to get to the ground or to a 5-volt level. So that's what happens with these two columns. The pins on them are connected, and most prototyping shields that I've seen and had experience with do have at least one power rail like this. Then either side of the power rail, we've got multiple rows in this case that have holes that are connected. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows that have the ground level conveyed among 3 holes each. So for example, I'll go to the first row and put my probe there in the first hole of the first row. And then you can see that the other 2 holes adjacent to the hole that I've got my black probe in are connected. But the one after that, so number 4, is not. So that's an individual hole. Same thing happens to the other side. So you've got your first row of the 5-volt column here. I put my black probe onto the first hole. Second and third are connected, but the one after it isn't. So keep that in mind as you are soldering. Another thing to notice here is that we've got traces like these, for example, and there's another one here, and there's another one here coming from the reset button. So there will be traces like that in your prototyping board, and it's a good idea to follow them and see where they go. So for example, the trace from pin number 4 of the button, if you follow it, will go all the way to the ICSP header here. There's another one like this one here. So from this pin of the ICSP header, we've got a trace that goes to the 5-volt pin. So I can actually test that with my multimeter, just turning it around so I can see what I'm doing. So there's probe there, and that you can see that those are connected. All right, and then we can also do the same thing with ground. So you can turn it around, you can see more traces, and this trace here conveys the ground signal to the ICSP header and to this pin right here. So if I touch, I believe it's this one here, touch this pin and that pin, you can see that these two are connected. Or that pin and I think it was this one here. Oh, no, can remember that one here. Yeah. So those are connected with a trace on the bottom side of the prototyping board. So probe around your prototyping board just to see what's connected to what, and also to have a look at the trace by looking at the traces and using your multimeter to figure out what's connected before you get started. Another thing before I actually start soldering, actually 2 things before I start soldering, is that you want to know which way is front and which way is the back, or actually how, actually I use my spare Arduino, how the prototyping board relates to your Arduino. So you can see that there's only one way to plug the prototyping board onto your Arduino, and it's this way. So that means that this side of the prototyping board is where the connectors on the Arduino go. And then that side is the side where the ICSP header is connected to. In the case of our robot, this is very useful to know because we want to know what the orientation of the prototyping board will be eventually once we plug it onto the Arduino. So the way that things are connected on the Arduino, the connectors of the Arduino Uno are on the left side, and then the headers are on the right side, which are facing to the front of the robot. So this is useful knowledge for me because this tells me that I need to connect my photoresistors on this side of the prototyping board facing forwards. And ideally, I'll be plugging in my screw terminals for the batteries on this side here, facing towards the back of the robot. All right. Another thing I should mention before we get started is that in terms of tools, apart from having a multimeter around, you will need a bit of solder. You'll need something to hold your prototyping board in place while you're doing all the soldering. You need a bit of spare wire. Thin wire is better, just a single core like this, so that you can easily connect it onto the holes of the prototyping board and therefore create traces, or the equivalent of traces, on a normal PCB. And then you need a tool to use with your wire so that you can remove the insulation of the wire to expose a bit of copper that you can then solder. You will need tweezers because you'll be working with little components. I use my Swiss Army knives so that I can use the pliers here to do things like, if needed, bend pins around in order to straighten them perhaps. So always useful to have these around. Cutters. We'll be cutting a lot of wire, and then leftover pins or pins from the bottom of the prototyping board. You will be making mistakes, like I will be making mistakes, so have a solder vacuum for that, just to suck out the solder. And spare parts, so I'll be using headers like these, so female and male headers, in order to connect my components. I have spare parts for everything that will go onto your prototyping board. Basically, what I'm doing is, instead of reusing the parts on the breadboard, I just found and collected a spare complete set of all of these components on the breadboard, so that I don't have to dismantle it, so that I have the chance of testing my prototyping shield before I remove the components from my breadboard for good. Hi, so in the previous lecture we completed the layout of the prototyping board, and I've got all the various components already soldered onto the board. And what we need to do in this lecture is to do the wiring. So we need to connect all the components together using either wires or just using solder bridges between the pads. To help us out with this work, I'll be referring to the schematic diagram. And there's no right and wrong way to go about this, so there's no particular place to start and to end. The way that I usually do this is to take care of the 5-volt components first, and then of the rest, in our case, then work with the motors. So what I plan to do is to start with the battery that provides power to the Arduino and the sensors, and take care of the switch, then connect that voltage into the V-in of the Arduino, and then do the wiring coming out of the 5 volts. So I'll be connecting the wires from the 5-volt pins to the potentiometer, to the photo sensors, and to the LEDs. And once I finish all that, I'm going to move on to the motor power from the battery to the switch and then to the motors. Another thing to be careful about is that I have already connected the capacitors onto what normally would be the 5-volt power rail. This one here, which, as you can see, there's a trace here that connects that to the 5-volt pin coming from the Arduino, this pin here. So I will need to use a knife and remove that trace, or to cut the trace, so that here eventually I'll have the 6 volts or whatever power provide to the motors, not the 5 volts that are coming from the Arduino's voltage regulator. So that's something to be careful about. Just going to do a little adjustment here for on the holder. Okay, so I will start with that. So don't forget that later I'm going to use my cutting tool to cut off the trace that connects a 5-volt pin from the Arduino with the 5-volt column of the power segment of the board right there. Because I'm afraid that if I don't do that now, I'll forget later. So I'm just going to say cut around here. And I'll use my multimeter in a minute to make sure that the trace has been properly cut. So just hack over it. Not very pretty, but you gotta do what you gotta do. Okay, let's test this. I've got my multimeter in continuity mode, and I'm just going to touch at either side of the cut that I created. So stay here and here. It looks like it's not connecting. Yeah, the tool is working, but I've just cut the trace. Just going to cut a little bit more, just to make sure that these two will never talk to each other. These two sides of this trace will never talk to each other again. Okay. Test again. Good. It's all gone. Where's the pin and the pad? These two talk to each other. Now the two ends of around the cut don't talk to each other. Okay, great. So moving on, taking care of the 5-volt part of the circuit. So battery that supplies power to the Arduino and its sensors will be connected to this screw terminal. So from here, I need to take power to Vin. So Vin, actually, sorry, from here, I need to go first to the switch that allows me to turn on and off the Arduino. And then from here, from the switch, we need to take power to Vin. From Vin, the power or the voltage will be taken into the Arduino's voltage regulator. It will regulate it to 5 volts and it will come out of the 5-volt pin. So I'll be able to grab it from here and then distribute it across the 5-volt components. So first step is to take voltage from this screw terminal into the switch and make sure that the switch actually works with that voltage. So there's a terminal that provides voltage from the Arduino battery, and these two are the pads that I want to connect together. And I'll show you why. Again, use the multimeter, and right now, let's move that up there. I would like that to be the off position and that to be the on position. So when the switch is in the off position, and I will use stickers here to note that on the board. So when the switch is on the off position, these two pads have no continuity. But when the switch is in the on position, like it is now, and these two pads all have continuity, like that. I'm just going to take a yellow wire and I'm going to use it to do a connection just like this, from that pad down to that pad right there, like that. So use a cutter to trim that wire right there. And I use my tool to remove some of the insulation at the tip of that wire, like that. And then place it onto the board. To bend the wire appropriately. So this takes a bit of patience. Can't hurry these things. A lot of patience, actually. So another strategy to do this is to use the tweezers and your soldering iron and solder one end of the wire at one side, and with that done, once that is done, then move the other side in place and finish the soldering there. So that's what I'll do, and to do that I'm actually going to use my left hand to hold the soldering iron, which is not my good hand, and try to secure that side of that connection. There you go. That looks a bit loose. I'll do it again. Okay, like looks solid. Great. Okay. Now on the other side, I can either try to take the wire directly onto the pad, but I'm just looking at the pad and it's not very, it doesn't have much space around it. So another strategy to go about is to just connect the end of that wire to the adjacent pad and then do a bridge over it. So that's what I'll do instead of connecting it directly. And because I've already soldered one end here, I don't have to worry about using any tape to secure the wire on to the board. So I'm just going to do that next. So pad it right next to the pad that I'm targeting. Done, and then bridge that over. There you go. Yeah, a bit of trouble there because the mask, the red mask that is on the PCB is designed to prevent this kind of bridging across. So that's why I had a bit of trouble doing that, but a bit of patience, it works eventually. I'm going to trim it off so that I don't have too much solder, because then that might make it very easy to cause a bridge between the pins that I don't want to connect together next. You can see also why it's important to have a bit of space around the components right here. Just zoom in. You can see that because of the amount of time it took me to complete this solder, the insulation of the wire was stripped off, it burned off or melted away down here in the bottom. So there is a small contact between the wire here and this pad. So if there was a component there on the other side, that potentially would have been soldered as well. But because I've left a bit of space, I don't have that problem, and I don't mind if there is contact between the wire and the pad right there. So it's good. So the next thing to do is to use another wire and connect this pad here to the end, which is right there. Just double checking and triple checking. So there's VN. So VN is this pin here. So I need a little wire that will allow me to connect that right there. So I can either go like this or like this. I might, not sure, either way is fine. So I'll probably make it go this way. So let's use a bit of wire here. I'll have to measure it first. Make sure that it's long enough. So like that. Yep. So I'm not speeding through this because I want to make sure that I get it right, because it's a hassle to fix those things if you don't get it right the first time. So I'm going to cut that through here and remove the insulation from both ends. Just a little bit, not even a millimeter is what I'm removing. Just like that. A bit more actually. There you go. It's good. And just like before, I will attach one side first. And then the other. I'm actually having second thoughts about that, and I think I should connect it like this. Reason being, I don't want to have a wire too close to this pad, because I'll be soldering things here later, so I'd rather go the other way around like this. The additional advantage of doing that is that I don't have to solder this wire using this pad here, which is too close to that pad. Instead, I can use these two pads to do the job like that. And I'll use a solder bridge to do the connection. So that looks like a better option. So let's go for that. Use my tweezers to keep the wire in place. Some more solder to get the bridge quite right. Whoa. Okay, so I've got the bridge done. We've got a lot of the insulative jacket also melted, which is okay. And then get that closer to the VN pin. What I'll do is I'm also going to bend the tip slightly towards the bottom. I can insert it into that opening of the pad right there. Yep. Okay, looks good, so let's do that. Okay, I didn't get burnt. Alright, so that's it. Gonna trim off some of the excess if I can, see if I can, some of excess solder here. Comes off easily, so I'll trim that off. Done. Alright, let's do some testing now with the multimeter. What I want to know is whether I have power here in VN from this screw terminal. Oh, sorry, hope you didn't miss all that. Okay, so I'm going to use my multimeter to make sure that the switch works as intended. So right now the switch is off. So let's see, one probe onto the screw terminal screw, the other one on VN, and no continuity. Switch it on. Try again. Yes, continuity. So if there was power connected to this terminal and the switch was towards the right, then the Arduino will be turned on now. Of course, we haven't done the ground pin yet. We'll do that soon. So the Arduino battery is connected into VN. So let's have a look at the ground next. So the middle terminal on the screw terminal is where I'll be connecting the common ground between the two batteries. And I'd like to take that over to this column here, so connect it to this column, and then from this column the ground level will be distributed to this pin here, which is this ground pin on the header. And also from this side here you can see there's a trace coming around into this pad, and from under this pad it gets distributed to this ground pin on this side, and then to the ICSP header. So by just using a jumper wire to connect this pin over to any one of the pads on this column, I have then a lot of other places around the prototyping shield that allow me to get the ground level signal from. Alright, so let's do that now. Probably the easiest thing to do first is to use a bit of solder to create a bridge between this pin and this row of pads. Lots of solder to create a bridge, and done. Bridge is done. Just clean up the tip a bit. Then, probably the easiest way to do to create the connection between this row and this column is by using a jumper wire. So I'm going to use a white jumper wire. It needs to be very small. I'm going to use my cutters to remove a bit of insulation on either side, since this little piece is too small for the wire tool. That's one end. There's the other end. So then I'll use my tweezers to bend the two ends downwards. In a way, I'm creating my own little jumper wire like that. And then I will insert this wire between the two capacitors over the top side of the breadboard, of the top side of the prototyping shield. Yep. Try again. Like that. So essentially I've got a jumper wire here. Should stay in place. Yep. Like that. Just move the yellow wire out of the way. Oops. Damage insulation a bit. It's okay. So now I can do the soldering, and I've got a connection between the ground row and this ground row here and the ground column. That's done. Try to avoid the yellow wire so it doesn't damage its insulation, and that is done. Great. Let's test it. So I've got ground in the middle screw terminal, and let's go to this ground pad here. Nope. Oh, sorry. It's my multimeter switched off. Right, okay, so back on. Yep, good. So first of all, make sure that these pads are connected. Yep. So it's just testing this and that. Any of those pads should work. There you go. Great. And then I will test this screw terminal with this ground pad. Great. And then this ground pad as well, and that is not connected because there's no trace between these two, so I need to be aware of that when I'm doing my wiring later. Great. And what about on the other side? We've got a ground pad right there, and that is also connected to ground. Great. Awesome. So let's see, what have we got so far? So on the diagram, we've connected the sensors to the 5-volt pin, to the in pin on the Arduino, and we've also connected the ground from the battery to the ground of the Arduino, so that bit is done. Alright, so the next thing to do is I want to do the connections between the 5-volt pin coming out of the Arduino and the sensors, so the photoresistor, the potentiometer, and the HC04 pin number 4, the VCC pin. Okay. So the first thing to do is to create a way to easily distribute the 5 volts from this pin or this pad, which is this pad right here, to the rest of the circuit. So probably a good way to do that is to provide a jumper wire that goes from this pad over to this column, perhaps even across the other side, but we'll start with just one column here. And I can do that by simply providing solder bridges. The first step, of course, will have to be a wire. So it can be a short wire. I'm going to actually remove insulation from it first, like that. And then cut the length that I need, bend the end of it, bend the other end. You could go for a longer length than this, but it's okay, that will do for now. And then insert that right there. I'm not too fussed about the solder, about the insulation, because I plan to use this whole column as 5 volts. So I just want to I just want this wire in order to jump this space between this pad and the column. So it's okay that it's exposed. Great. Take that across to the other side. Great, done. And I'm going to create a little jumper, a little solder bridge with the pad across it. It's not easy. So what I'll do, I'll remove the excess solder and use a small wire, one of the cutoffs from pins that I used earlier, to do the jump. Right. So here's a pin I used earlier, and I will use that pin to extend the number of pads that I have soldered together, conveying the 5 volt signal. Alright, so I've already got a bit of solder, enough to keep that wire there on the tip of the soldering iron. Alright, so this is my 5 volt power rail now. So let's do the photoresistors. So with the photoresistors, the 5 volt signal is connected to the side of the photoresistor that's got this 3 pin on both photoresistors. So it means that this pin for the left photoresistor and this pin from the right photoresistor should be connected to the 5 volt rail right there. So there's the 3 pin for the right photoresistor and the 3 pin for the left photoresistor. So those need to go over there. So probably the easiest way to do that is to use a single wire. We'll take the 5 volts over here and then another wire from here down here. So I'll use a white wire for that. Let's test it now. So use my multimeter, and this pin is 5 volts from the Arduino, and we need 5 volts on the photo resistor. Enable the appropriate continuity mode. Great. Okay, that's what I want. So I'm going to take another wire now and connect this to that pin in the same way again. So let's test it. So 5 volts pin right there, and photoresistor. Great, we've got 5 volts going over there. Right, so let's mark that out. Let's mark that off the list. So that's done. And that is also done. All right, next, let's do the same 5 volts for the potentiometer. Okay, so with the potentiometer, because it's symmetrical, it doesn't really matter which one of the 2 pins in the bottom I do, so that or that, either one will be fine. So what I'll do, I think, is just use a wire to a short wire to solder this pin here, which is closest to the this 5 volt rail, to this 5 volt pin over here. So I'll connect this to that. And as always, test it. I should be able to get 5 volts from up here, this pin, all the way to the pot. Great. All right, next. This bit is done. So this bit is done. So next I'd like to do the 5 volts for the ultrasonic distance sensor. So I've got to be careful here with how I plan to connect the jumper wire coming from the ultrasonic distance sensor. So right now, the way that I've got it set up, I've got the VCC is the green wire, and I'm just going to take it off the breadboard and just briefly connect it onto my prototyping board. And that's how I would like things to look like eventually. So I would like VCC to be on the left side of the header. As I turn this over, it means that this pin here should be the one that conveys the 5 volts. So all I've got to do in that case is to get a little jumper wire and connect this pin here to this pin here. It's probably the easiest one. I could try and remove some insulation out of this wire, but I think it's going to be messy, and it's going to make it's going to look the board look messy after the blackened wire stays in. But I'm going to connect this to that. I could also go for this pin to that pin, but this already has 2 connections terminating there, so I don't want the solder blob to become too big. So that's what's going to be, that to that. Let's test. Always test as you go. Minimize nasty surprises later. So from this pin down here, the 5 volt pin, all the way to the VCC pin for the ultrasonic distance sensor, we've got 5 volts all the way. Great. Let's cross one more thing out of the diagram here. So we've also done this bit. Great. So what I want to do next is to connect the potentiometer and the photo sensors to the analog pins. So start with the potentiometer that goes to analog pin 4. So here's a potentiometer, and the pin on top should go to analog pin number 4. So this is analog pin number 4, and this is the potentiometer pin where the signal is coming out of. So I need to connect that to that. Right, let's grab a got yellow, let's grab a blue wire for the signals. Let's check for continuity. So from the potentiometer signal pin to pin number 4. Yep, good. Next. So we are all done with the potentiometer. So this is completed. Then we need to go for the photoresistors. So the signal pin for the left photoresistor should go to analog pin 2. And the signal pin for the right photoresistor goes to analog pin 0. Right. Okay, so which one is the left photoresistor? Remember, this is the back, this is the front. So the left photoresistor is this one here. So the pin that connects the resistor, the fixed resistor, to the photoresistor on the left side should go to analog pin 2. So analog pin 2 is this pin here. 0, 1, 2. Okay, turn it around. So this pin needs to go to 0, 1, 2. This pad here. All right. So we want this pin to be connected to analog pin 2. That's good. Make sure there's no bridges that I can't see in adjacent pins. Yeah. Or here. Great. Done. So back to the schematic diagram. So I've done the left side. So now we need to do the right side. So the right side will go to digital pin 0. So digital pin 0, oh sorry, analog pin 0. So analog pin 0 is this one here. The photoresistor on the right side is this one here. So we're looking for the junction between the resistor and the photoresistor connected to analog pin 0. So flip it over. So here is analog pin 0, and the junction between the two is this one here. Right, so I'll probably use a bit of a very small amount of blue wire. So from here to here should be connected. Yep, but none of the others. Yep, great. Okay, back to the schematic. So that bit is also done. So we are finished with the photoresistors and the potentiometer. So the next thing that I'd like to do is to finish up with the LEDs and with the HSR and with the ultrasonic distance sensor. And then the only thing that will be left to do is to work on the servos. Right, so let's do the LEDs first. I'd like the right LED to be connected to digital pin 5. Right. So this is the front of the board. So this is the right side. So the right LED, I'd like that to be connected to digital pin 5. So digital pin 5 is this pin right here. Right there, that's its pad. So 0, 1, 2, 3, 4, 5. So flip it over, and it's this pin here that I would like to connect to 0, 1, 2, 3, 4, 5. So this pad right there. 0, 1, 2. So the third one from the left. So let's use. I'll go for blue again. So this is digital pin 5 and this is the LED, and it works. Great. Just untangling the soldering iron. So the LED on the right side is done. So let's do the one on the left side. So that should go to digital pin 4. So the left side is this LED here, and digital pin 4 is right there. It's much closer, right next to 5. So flip it over, and what we need to do is to connect this pin over to 0, 1, 2, 0, 1, 2, 3, 4, right there. Let's see if we've got this connected properly. So from here to here, yep, and the two pins next to each other are not soldered, so that's great. All right, let's update our schematic. So we've also done the left LED, going to digital pin 4. Now, what I want to do next is to connect the echo pin to digital pin 2 and the trigger pin to digital pin 3, and that will complete the work on the Arduino parts that involve sensors and LEDs, and then we'll move on to the motors to conclude. So let's work on echo first to digital pin 2. So now, double check. The echo pin on the sensor is the one that is right next to ground. So in our case, this is ground and this is echo. The echo pin needs to be connected to digital pin 2, which is this pin right here. So this is the echo pin on the sensor's header, and here is digital pin 2. So on the other side, this is the echo pin, and this is digital pin 0, 1, 2. This one right here. So it is a bit cramped, so I can see it, but I'm thinking that what I can do is to use a jumper wire that goes from here, digital pin 2, and I will insert it right here. So double checking 0, 1, 2, 0, 1, 2, so 0, 1, 2. From here to here is what I need to do next. Let's check. So digital pin 2 and the end of the blue wire. Yep, that works. But now, of course, I also need to create a bridge between these two pads. So from the echo pin on the header to digital pin 2. Yeah, so they're connected. All right. Now, a little problem that I'm having is that the trigger pin right next to it, the pad that was available to use in order to connect that is right under this blue wire. So I won't be able to go directly to it. So I may be able to use... okay. Right, so what I'll do here is... Okay, so let's check out the schematic. So we've got the echo pin connected. And the last thing to do here is to connect the trigger pin. Actually, I shouldn't connect it yet. So trigger pin goes to pin number 3, digital pin 3. So looking at the work done so far, the problem is that the trigger pin is this one right here, and the pad next to it is not easily accessible because the blue wire is right on top of it. On the other side, I've got the white wire going over it, but at least that's insulated. So I need to then connect this pin to digital pin 3, which is 0, 1, 2, 3. So this pad here corresponds to digital pin number 3. So I'm going to have to go over it. So what I'll do is I'm going to use just to keep things separate, I'm going to use a yellow, to make things a bit more visual, I'm going to use a yellow jumper wire. So that and that should be connected. I'll try it from the underside actually. Alright, so this and this one here, this pin and that should be connected, yes. Alright. Great. So let's see, what did we just complete? So that trigger pin is also done. So the ultrasonic distance sensor, the LEDs are all finished. So it looks like the only thing that's left to do now are the servos. So let's do that next. Next, we can go and finish up the connections for the photoresistors, the potentiometer, and then work on the LED. So let's work on the potentiometer, I want now to work on the grounds, So the second pin on the other side of the VCC pin for the potentiometer is ground. So I'll take that to ground, and then I'll do grounds for the resistors as well, and for the ultrasonic sensor. All right, so flip that over, and this pin here is what I want to take to ground. Now let's look, where is ground? So we've got ground here. We also have ground, just following this trace, we also have ground right here. And we also have ground from the top side here, and then here. So probably from here, I think I'm just going to take advantage of this nice big column and just connect my ground there. Yep. So this is how I'll do it. I'll take a blue wire just to show that this, actually I'll take black. We've got black, so I'll use black. I'm going to take a bit of this black wire, and I plan to connect it like this from here to here. Maybe the first couple of pins would do it. Yep, so I'm going to cut a bit off, remove some insulation on both sides. I'm going to remove some more insulation on the other side like that. And bend it on one side so that I can insert it in like that. And then on the left side, I will turn it over like this. Like that, right? And all I need to do then is to insert the tip into one of those available pads. So I will do a bit more trimming. Remove some insulation from the tip. And bend it downwards like that. Let's put that in. Like that. Yep, that should work. Doesn't matter if it's not exactly 90 degrees. It's okay. All right, let's put that in. Solder. Great. All right, so I think that's done. Let's test it. So we want any of those pads, since they belong to the ground level, to convey all the way to the potentiometer, this pin here. Great. Yep, done. So this bit is done. So the next wiring to do is with the resistors. So the other side of the photoresistors, the other side of the resistors that match the photoresistors should go to ground. So we're looking for the 3 pins for the fixed resistors. Okay, so here's our resistors, and it's this pin here that we want to connect to ground. Let's see, what's the best option here? Probably, so from this one here, I'll bridge it over this that side, and then from here I would use a black wire to connect it to the ground rail, and on the other side I could connect it either to this on the potentiometer, it's probably not a bad option, or again all the way to ground. Just to minimize the fuss, I'll just connect it here. Yep. Alright, so I'll start with the top one. Another black wire. Remove insulation from the top side. And I'd like it to go around here. And then need to bend it a bit in order to go around other wires. So I'm cutting this slightly larger than absolutely necessary. So bend it downwards to insert it into the pad. Same thing with both sides, actually. I'll do the top side later. So I'd like that to go in there. Like that. And the other end, I'll worry about the other end in a minute. So the other end, I will turn that pin, that wire downwards so that I can connect it to the pad like that. Alright, so I want this pin here, that is the free end of the resistor, to be connected to the same level as all the pads on this column. So I'll just touch here. Yes, good. And same thing with that. And the potentiometer. Great. So I'll do the same thing now for the second resistor, this one here. So that resistor here, its free end is that. So we'll connect that to its nearest ground location, which is this one here on the potentiometer. All right, let's test. Make sure everything is as it should be. So anywhere on the ground column to the resistor, it works. All my grounds seem to be good. Great, okay. So let's see, where are we up to now? So we have done these bits as well. I need to do the ground for the ultrasonic sensor next. All right. So the ultrasonic sensor, I've already done the VCC. So looking at the sensor, we can see that the other end of the header is where the ground signal goes. So that means that this pin here will be ground. Therefore, this is the pin that I need to connect it to the ground. Now, the closest one would be this pin here on the resistor. So I'll need a small jumper wire to connect that to that. So let's test. So here's the ground column, and here is the ultrasonic sensor ground pin. Great. So all the grounds are done. Let's see where we're at. Just hit the ground. Awesome. And the last set of grounds that I need to connect are those coming out of the fixed resistors for the LEDs. Right, these are the cathodes. So here's the resistors for the LEDs, and these are the pins that I need to connect to ground. So flip that over. So on this side, it's this pin here that needs to go to ground. And the bottom side, it's this pin here that needs to go to ground. So I'll do the bottom side first. The easiest thing to do is to just bend it over the adjacent pads. And you can see then all I need to do is to bridge that to that. So it looks quite easy. So let's do that. It looks okay, let's test it. Alright, so ground to the resistor. Yeah. Just be mindful of the third pin of the potentiometer. We'll have to connect it to one of the analog pins later, but for now it is well clear of everything else around it. And the other thing that I need, the last ground that I need to connect is this one here. So I could probably pass a wire, a black wire, under the yellow wire or over it. It's no big difference either way. And then onto this junction here. Right, so I've got a bit of wire here. That should be long enough for the job. I'll have to go over the yellow wire. Yeah, that will do the job. So let's trim it. All right, so that's the last LED. Let's test it. The resistor for the LED on the ground. So that should connect easily to all that. Yep. Going to check all of the grounds. Okay, and I make sure that I haven't connected the ground to the 5 volts. So I'm going to touch all of the white wires, and all that looks good. Okay, where are we up to now? So I've also done these. Right, so I just had a quick break and I'm coming back to continue with the wiring and just having a look at where we are at the moment. So we finished with the sensors and the potentiometer, the header for the ultrasonic sensor, and the LEDs are all done. I've also got the switch for the battery that supplies power to the Arduino and the sensors completed. For the motors, we need to wire in the wires that convey the positive voltage and the ground. And we also need to wire the signal wires to the PWM pins. I'm going to start with the power components, with the power wirings, and connect the battery to the switch, and then connect the black and red wires from the motors to the ground rail and to the battery, the motor battery positive rail. And then I'm going to work on the signals. One thing that we've completed already, I'll just mark that as completed, are the capacitors. So I'm just using 2 capacitors instead of 3, and those capacitors are already inserted between the ground and the 6-volt positive rail in this part of the prototyping shield. So I'm going to continue now with connecting the switch to the battery. All right, so let's have a look at the, just a minute, let's have a look at the prototyping board. So we've already dealt with the ground terminal and the Arduino terminal. Now we need to work on the motor terminal at the M. This is the terminal that conveys the positive voltage from the battery that I will be using with the motors. From here, we need to convey that voltage to the second switch. This is the motor switch up here, so it's this switch here. So we need to connect this to this switch, and then from this switch we want to convey the voltage over to the positive rail right there, which is connected to the positive side of the capacitors. So now the question is, which one of the poles of the switch should I connect? So let's use the multimeter again. You can set it to continuity testing. And I want to see what the positions of the switch are before I decide how to connect the switch to the battery. So right now the position is off. I'm going to call this off just like we did with the bottom switch. When that position of the switch is off, then these 2 poles do not convey electricity. I'm going to push the switch now to the right and see what happens with those 2 poles. So now they convey electricity. Okay, so what I want to do with this information is I'm going to take the voltage from this pin, that's from the motor terminal on the screw terminal, connect it to this pin here, and then from this pin I'm going to use a wire to connect that voltage to this rail here, the motor positive voltage rail. And then from there I will distribute the positive voltage to the motors. So let's do that. I'm going to use a red jumper wire for that. Okay, so let's check it. This should be the off position, so let's make sure that there is no connection between the battery pin and the power rail. Good. Let's push it to the on position now, and there should be a connection between this pin and this rail. Yes, great, awesome. Okay. And before I forget, I'd like to put the labels next to the switches so that I know which way is on, which way is off, and which switch is for which part of the circuit. So the one on top is for the motors. I'm going to stick that here. And the one at the bottom is for the Arduino and its various peripherals. And I'll put that right here. Need my tweezers for that. It's right there. Okay, now where are we? Looking at the schematic, we've just connected this and this to the power rail. So now I'm going to connect the middle pin of the 3 headers to the positive supply voltage from the motor battery, which happens to be 6 volts here. So that is the middle pin for the 3 headers. So the middle pin for these 3 headers. So flip it over and we've got this, and this pin. We need to connect it to somewhere on this, one of the pads on this column. So let's use, probably a good way to do that would be to first, I need to lift this wire up temporarily and I can push it down again. So what I'd like to do is to first connect these 2 pads together and then connect it to the 3rd pad right under this blue wire. Like that. Be careful when you move wires around like this, because it might actually lift the pad on which the ends are connected, but here I've got enough distance, so that should be okay. So I think that this is done. I'm going to measure first, make sure that the 2 pins on either side are connected. Nope. Yeah, so there is the bridge out here at the edge. Between this pin and that bridge needs a little bit more solder. Okay, so that looks good now. Let's test it. Yes, that's good. So then I've got one more pin, which is this one here, that I would need to connect. Probably the best way to do that is to use a red jumper wire. Yep, that should do it. Before I solder that, I just want to make sure that this last solder has not interfered with the 5 volt rail that I created earlier. Yeah, it looks okay. And I can see a gap right under here, so that the red wire is not really touching on the 5 volt power rail that we created here earlier in this column, so it's okay. Now hopefully when I go ahead to solder the wire onto the last pin, we're not going to melt the blue wire there. Before I do that, I just need to push that further down a little bit more. There you go, so that it doesn't touch the blue wire at all. Right there. Okay. So let's do that solder. Right there. Right, let's test now the conductivity of those 3 middle pins. Those convey the 5 volts to the motors. Oh, sorry, the supply voltage, whatever that might be, to the motors. So that, yep, they're all good. Okay, great. So visually on the schematic, what we've just done is to connect those pins together. And the next thing I need to do is to connect this one here, the remaining segment, in order to connect the 3 red wires to the power supply. Okay, so how do we do that? So what we want to do is to connect, let's go a bit closer here, is to connect this red wire or this bundle here to any one of the pads here. So grab another red wire. And one way to do it would be to insert that down there. Just getting a bit crowded though, so I'm a bit worried about that. I need to leave enough space for the adjoining pins to be connected to the ground and to the signals. So I'll try to, I will try to go straight. So over, so I'm going to push the blue wire like that, over like that, and then I'm going to do my connection right there. There's a bit of the wire from the red jumper wire still exposed. So I'm going to be able to connect onto that and then to jump over to the power rail. Right, so done. Okay, let's check it out. The switch is on for the motors, and I will test to make sure that we've got the same, we've got a connection between the voltage supply for the motors and the middle pins for the motors. All right, so motor, yep, yes, yes, and if the switch is off, no, no, no. What about the grounds? We haven't done the grounds yet. Of course. Speaking of ground though, should be able to get a connection here, yes. And here, yes, okay. Right, so let's see, what did we do so far? So the last connection we did was this one here. Great, so next, let's do the black wires, so the grounds. So I can choose which, so I can choose whether I'd like this to be ground or that to be ground, but I need to be consistent for all headers. So if I decide that this should be the ground, then it should be the ground for all of the headers, and then this should be the signal. So let's see what the situation is on the other side. So our headers are right here, 1, 2, 3. Should use a tweezer for it's got a pointy end. So 1, 2, 3. The middle is the positive voltage. Then I can choose either this or this to be the ground, and whichever one I choose, the other one should be the signal. And that's because the headers from the motors, here's one, can either be connected like this or like that. At this point it doesn't really matter. I can do whatever is more convenient for the sake of the wiring. So let's see if I'll turn the board over and see what is more convenient. I need to connect the signal wires to digital pins 6, 11 and 10. So these are all on the digital pins header. So from here, I will need to go here. So it looks like to me it's easier to connect those pins to any of the pins on the digital header via versus these. I would have to jump over other pins. So okay, so what I'll do is I'm going to connect these to ground, and then these to the signal pins. And while I'm at this, I will trim some pointy ends from previous soldering so that they don't interfere. Alright, so I'm going to use the same technique as earlier. I'm going to use a previous pin, to help me create a bridge right there, just like that. So let's trim this a bit to make it fit. Maybe slightly more. Okay, and to make it a bit easier, I'm going to deposit a bit of solder on those two pads, and then I'm going to put that pin right there. So 5 volts, still okay, and there's no short circuit between the two. Right, so let's try again. I need to add a bit more solder between the pin on the left and the bridge on the right. Okay, that should do it. Let's test it. Great, okay, that's good. And then I'm going to use a black wire since we are doing ground here. To connect this bridge with this pin. Let's test it. Great. The last thing to do here is to connect this to anything that has a black wire going to it. So if I could go from here to here, for example, that's probably the easiest thing to do. So any one of those pads, ground pads, should have a connection to any one of those pins. Yeah. Great. Right. It's good. So back on the schematic. We are getting there. We're very close. Where is my blue pen? I'm sure I had it. Oh, here it is. So what we've just done was to finish with those connections and connect all the way to the common ground. So there's only 3 wires left to do, and that's the signal wires. So I need to connect, let's start maybe with the middle one. That's the easiest one for not making mistakes, because I have connected the micro servo in the middle of the, so the micro servo is the middle one of the 3 headers. So I'd like that to go to pin number 6, digital pin 6. So at the moment what we have, let's do a check. We've got the ground pin, which the pins on the right side as you're looking at the board, like this. So this is the front, this is the back, this is the right, and this is the left. So the first pin from the right, the first pin from the right is the ground pin, and we've tested that to be properly connected. Yes. Now the middle pin, this one here, is the positive pins for the motors. So we've tested them that they are all connected to each other, and with the switch, the motor switch on, the terminal, the positive voltage terminal, and those pins are also connected. Right, so what's left to do is to connect the signal pins. So the first pin from the left are the signal pins, and the one in the middle is the one that will be providing the signaling to the micro servo that moves the sensor around. So this pin here, which is this pin right here, needs to go to digital pin number 6. Which is this pin right here. So it's the second from the left. So it's this pin right here. So I need to connect this pin to this pin. Okay, let's use a yellow jumper wire for that. So yellow jumper wire, cut a piece off. Remove insulation from one end, and let's measure then. Double check that I really soldered that into digital pin 6. Yep, that's right there. I should also test it just for the sake of sanity, because I've been working on this for about maybe 3 hours now, so I want to make sure that I've got the right pins. Yep, okay, that's good. And again, this pin here is that, should be. Yep, that's it, that's good. And then I'm going to get that pin, just bend it the other way, like that, as close as I can, but not over it, but under it, like that, as close as I can to that pin right there. And then solder it. From this pin to this pin. Great. And again, from this pin here to pin number 6. Good, great, okay. So let's mark that one out as well. The mini servo signal pin, done. Next, let's go for the left continuous rotation servo. That should be connected to, it's hard to see the line, the digital pin number 10. So the servo on the left should go to digital pin number 10. And so that there is no confusion, I will label it as well. Should have done that earlier, but never too late. I wanted to leave the labels for later because they may interfere with the soldering, but it's okay. I'm going to do it now. So this is the left, motor left ML. And this is the right motor, MR. And the one in the middle is the motor for the sensor. So actually I didn't really need the M. So obviously these are for the motors. So I could have just said left, right, sensor. Okay. I need another indicator here to tell me which ones is the signal, the positive voltage, and then the ground. But I can do that later. All right. So as we were saying, the left servo signal should go to digital pin number 10. So this is the left, so it means that this pin here needs to go to digital pin number 10, that one up there. So there's 1, 2, 3. So 1, 2, 3, this one here needs to go to this pin right here. It's going to be tricky again. I'm going to push that blue wire to the side. Like that. And I'm going to use the same technique for that. And let's double check that this is a good solder. So that with that. Oh, sorry. Multimeter is turned off. Okay. So that and that. Great. Turn it over. And make sure motor on the left is properly connected to digital pin number 10. Great. All right. So let's mark that off the wire, the diagram as well. So left is done. So last one is the right motor. Sorry about that. So the right motor signal should go to digital pin 11. Okay. So this pin here should go to digital pin 11 up there. All right. So is this going to be long enough? Might be. So digital pin 11 is right next to digital pin 10. So 1, 2, 3, 4. It's number 4 from the right. So it is 1, 2, 3, 4. It's this one right here. And that needs to go to this pin right here. So yeah, I think this is a good length. I think that's it. Let's check it to make sure that I haven't done any bridges. It looks good. Oh, hang on. Yes, okay, that's fine. And with a pin, yup, flip it over. So we want this pin to go to digital pin 11. Great. All right, let's mark that off. So the signal pin for the right motor is also completed. So done, done, done. So it looks like everything that needed to be done is done. All right, let's have a break and then we'll test the robot with the prototyping shield completed.